Hello everyone, welcome back to Advent Code 2024. We're going to start right away on day 11. Plutonian Pebbles. The ancient civilization on Pluto was known for its ability to manipulate space-time. And while the historians explore their infinite corridors, you've noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Sometimes the number engraved on a stone changes. Other times, a stone might split in two, causing all the other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first applicable rule in this list. If the stone is engraved with the number 0, it's replaced by a stone engraved with the number 1. If the stone is engraved with a number that has an even number of digits, it's replaced by 2 stones. The left half of the digits are on the new left stone, the right half on the new right stone. And they don't keep extra leading zeros. Sure. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved. Interesting. So a 0 turns into a 1, and then a 1 turns into a 2024, which then splits into a 20 and a 24, and those split into like a 2 and a 0. Interesting. No matter how they change, their order is preserved. They stay on their perfectly straight line. What happens if you keep blinking at them? So, if you have an arrangement of 5 stones engraved with these numbers and you blink once, the stones transform as follows. Yeah. So I would bet that in part 1, you can just write a function that like simulates this behavior step by step, right? It's going to say you blink 100 times or something. 25 times. And part 2 is going to be, well, what if you blinked 1,000,000 times or something like that? Because this behavior looks very much like it should loop, right? Like you could just write a function that does a little bit of arithmetic on a stone and a number of time steps. And tells you how many stones will be there after that many time steps. Like this sounds like the kind of thing that now it doesn't just put that stone's number. It puts that stone's number. Sorry, it doesn't just put 2024. It does if the number is 1. But multiplying by 2024 doesn't mean everything that doesn't fit goes to exactly 2024. It goes to a much larger number. Like, there must be something special about these rules. I mean, maybe not. Maybe part 2 is going to be, oh, by the way, there's another new rule for how stones behave, but I doubt it. Like, yeah, I guess this is the point. After blinking 25 times, 5 stones have turned into 50,000 stones, right? So, 25 times, I mean. It's turned 5 into 50,000. So, like, because stones can divide into 2, and then each of those can start multiplying, There's some exponential behavior here. I kind of want, before I work on part 1 directly, I want to just do some samples of, what happens to so let's say you took a number x, right? That's what you want to know, is like, I have a stone labeled x, and I'm going to go n turns. How many stones do I have left? Or do I have at the end of that? And I don't see any obvious algebra that should definitely tell you. It's like, even if you multiply, as this 7 demonstrates, if you multiply by 2024, you don't even necessarily get something that divides. You might get something like this that increases again before it starts dividing. Huh. Well, maybe the answer isn't algebra, but dynamic programming? I don't know. I mean, I'm trying to solve a problem that I haven't been given yet, but I would bet you $20. I wouldn't bet my life savings or anything, but I would bet you $20 that part 2 is going to say, actually, you didn't blink 25 times, you blinked 100 times or something. Or 1,000 times. Probably not 1,000,000. That's going to be too many stones. But if 25 blinks multiplies the number of stones by a factor of 10,000, then 100 blinks is going to multiply by 10,000 to the 4th, which is 10 to the 16th, which is what? Billion is 9 trillion quadrillion. Yeah, so 10 quadrillion stones, or 10 quadrillion times as many stones, even if you only blink 100 times. There's no way that you could write a computer program that just does that by hand for each stone. But there's going to be a bunch of duplication, right? Where we're going to see the stone 0 many, many times, or 1 or something. Sure, either way. And if we have a function that tells us, hey, the stone 0 after n steps turns into k other stones, then every time a stone splits into one of the sides being a 0 and the other one being a whatever, then we won't have to simulate that stone anymore. We can just look up, oh, well, it split into a 0 at step 13. How many stones does it turn into? How many stones does 0 turn into after? It split at step 17, I'm saying, so after 83 more steps, and we could just look that up instead of doing, a quadrillion things with it. So that sort of makes sense. And we could very well have, I don't think we want an array of the results. Yesterday's problem, we had an array and we used dynamic programming to save the costs of repeated lookups, although it was a small enough problem we could have just not done any of that and it would have been simpler. But here, we don't really want an array that's 2 million elements, right? So, you could use an int map, and I think that's fine, because this might be somewhat sparse. It might not be all that sparse, but I don't know what the upper limit of it is. And it'll probably be sparse near the upper limit at least. So what exactly is the function you would want to store for each stone? So here are the rules. I'm not sure. Like, at some point, you kind of want to say, like, A, how long until this stone becomes 0? But that doesn't really make sense, does it? Let's do a little experiment where... Oh, maybe they've already done this. A 0 turns into a 1. Turns into a 2024. Yeah, see, look. When you get to 1, 2024, 20 and 24, 2, 0, 2, and 4. What happens to these? 2048, the 0 turns into a 1. Sorry, 4048, 4048, 8096. So, like, these two 4048s, for example, will have exactly the same behavior. And we don't need to, like, do them independently. And I imagine, like, you know, this one is about to split into 4, 0, 4, and 8, right? Well, it's going to split into 40 and 48, and then 4, 0, 4, and 8. And the 0 is going to start this whole process over again. But I think, like, I don't know. I mean, I guess 8096. Is that really... I guess it's 4048 times 2. Where did this come from? It's this times 2024. Okay. Like, this is going to split into 80 and 96. So there's some function. Maybe it really is as simple as caching for a number and a number of, like, for a stone label and a number of steps, how many stones it has produced by that time step. Does that make sense? And that... But then I would never find any hits in my loop, right? Because I would avoid... Well, maybe I would. Because if we had these set of stones, the fact that they're arranged in a line is sort of a little bit misleading because they don't interact with each other in any way. Their linear order doesn't matter. You could sort the list, keeping track not of a set of a bajillion stones, but a map from stone label to how many of that stone do I have. And then you can just actually, for each of those, like, if I had 100 stones labeled 1, next step, I would have 100 stones labeled 2024, right? And all the stones labeled 1 would go away. Maybe that's enough. Because if my idea is that there will be mostly duplicates in this list of stones, mostly small duplicates, there's not really anything to cache. Like, I think there's some, like, when you get to a 1, like, it turns into 2024, this 0 turns back into a 1, this 2, like, turns into 40, 48, like, and that produces a 0 eventually. Like, there's something there about the cycle. Like, you could tell exactly, somehow, you could say, like, oh, a 1 after 10 iterations turns into, like, well, 3 zeros, 8 ones, and an 8096 or something, right? Like, and you could somehow use that to do something smart. But I think if you just manage a multiset rather than an actual linear list, you'll get most of the advantage of that with a lot less of the algebra. And I don't even know if the algebra actually yields anything. Like, I'm sure you could simplify somehow, but I don't know the details. And I assume the numbers of stones we have are small enough to fit into an int set, or a multiset, excuse me. Because it has to be a number we can enter here, and generally speaking, that will mean it has to be 64 bits or less, because Eric doesn't make people use big ints. So that might be all that we need to solve this puzzle. Let's try that. My input is small. I mean, that's not a surprise. I thought it would be a little bit bigger than this because the test input is 5 numbers and this is 8. Usually it's bigger by a factor of like 100 or something, not by 2. But that's fine. Oops. No, this is not what I wanted anyway. Close that buffer. Okay. So we want an int map. And my input is an m.map. Actually, is it called map or int map inside that package? I think it's a map, but I'm not sure. Nope, it's an int map. Okay. They could have just called it map because it's qualified by m, but because you can import it qualified anyway, but they didn't. Okay, it's an int map of int? Yes. Well, it's a little bit, like, I kind of want to distinguish between the ints that are the labels and the ints that are the values. So let's say type label label. Label is int. Type label is not label. Type quantity is also int. And this way I can at least say it's an int map of quantity. I can't call this a label map. But it is an int map. So, I mean, okay. That's what my input is. And I think I would like to just use very basic parsing here. I don't need a regex. The pair is m.fromList width of plus, which, I mean, our input is so short, we could just, like, I know there aren't any duplicates here. I could just say, oh, it's, make an int map, but we'll say plus in case I like my solutions to be general enough to work no matter what the input is, as long as it's input that fits the criteria described in the problem. So I will handle duplicates here, even though I don't have any. From list with plus of read a word 1 for W in words of input. Now we could write this as a map instead, but the list comprehension is concise and readable here. So does this compile? Yes. And if I said, what is prepare of read file input.text? It's a list. We have a 1, we have a 6, an 11, and so on. Perfect. So what I want then is a function that, given a label, you know what, I actually want a new name for this. It's stones, and type stones is this, because I want to be able to discuss stone lists or stone counts without having to talk explicitly about input. So I want to define a function that takes a label and produces a stone counts. It doesn't produce an input. That doesn't really make sense. It produces a stone counts. So step takes a label and produces a stone counts. Step of, I have to go consult the rule book, but step of 0 is 1, right? Yeah. Step 0 is singleton. I assume that's what that's called. Let me go look. Yep. Singleton key value, of course. Singleton 1, 1. Great. Step 1, no. Incorrect. Step anything other than 0, I guess, is case split. And it's proposing split from some the random generator thing, splittable random numbers. But we're defining a new function called split, not importing this one. So if we can split into an A and a B, then it's m.fromList. Well, I guess we have to be careful, because if A and B are the same, we should produce 2 copies of it. We can't just say it's from list and there won't be any collisions, because if we might get a stone labeled 2020 and it could split into 20 and 20. So m.fromList with, let's actually Freaks takes a list of quantity. Yes. Is this right? No, it takes a list of label and produces stone counts, I guess. Freaks is from list with plus composed with map of make the quantity be 1. So then here I can say freaks AB, and here I can say freaks map read words. So we convert the input to list of words, Convert each word into an int, and those are labels. Then we call freaks. Wait, so freaks doesn't want... Wait. It wants a list of labels, of course. So we make the quantity be 1. Yeah, I mean, this looks okay. Does it compile? Almost. I didn't define split. Turns into a 0 if it doesn't, none of the other rules apply, right? No. Wrong. None of the other rules apply. Right, you multiply by 2024, of course. Where split is undefined. So does this type check? Almost. Couldn't match string to stone counts. Yes. When I made this point free, I didn't remove the function parameter. Okay. And prepare still returns the same result. Nice. But now we have to define the split function. I guess it's fine to just do this with strings. It would be a lot more efficient, I suspect, to use, like, I don't even know an efficient way to compute how many digits are in a number. That's an interesting question to ask, I guess. Efficient digit count of int. So we're looking around on Stack Overflow here. Okay, yes, very funny. Yeah, that's true. There's a function that can do it in just one bit. Or one instruction, probably, on many CPUs. Yeah, this is awful. I don't like any of this. But I wonder if there is something in Haskell. Maybe there's something Haskell specific where, like, it can digit count of, yeah, convert it to a string, divide to, yeah, but like, there's not really anything good that I can find in these Google searches. Okay, well, we'll just do it the obvious and easy, but not very fast way. Split n is let s equals show n in len equal s div 2? No, that's not what I want. That's not what I want at all. I don't want to divide the string by 2. I want to be the length of the string. Okay, that's better. Actually, why am I putting this all in a let instead of a where, the natural way to do it? Where S is show n, len of length s, even. Now I can just do it. If even len is read. I'll just say int. Well, it's just read, really, right? This function split at in data list, right? Yeah, okay. So let's import that. And does it always return a tuple? It does. It doesn't like... I assume... What happens if you give it a number that's out of range? If n is negative, it returns an empty list. And I guess if n is greater than the size of the list, then it just like gives you an empty list on the right, probably. Yeah. Okay. So that's fine. Really, like, I want bimap, but it's so stupid to import data bifunctor for this tiny little problem. I don't know. I'll just do it. Bimap read of split at len div to s. Does that make sense? In fact, split should really be a top-level function. Right. Split takes a label and returns a list of label. Well, this isn't really... I wanted it to be a top-level thing because I wanted to test it. This is not right at all. It returns maybe a pair of label, right? Yeah. So it's just this. Otherwise, it's nothing. I think that handles the three rules. Does this compile at all? Split at? Did I not use split at? What do you mean it's redundant? Is it actually in Prelude? Oh, okay. So suppose then that we tested it. Split of 5 should be 5. Should be nothing, right? Yeah. So the 50 should be 5 and 0? Yeah. Okay. 501, 505, 5012. Yeah, that seems like it's working. So that means we could say step of, 10. That should be 1 and 0 in the list. Yeah, there's a 0. There's a 0 and a 1. And if I said step of 1, it says, oh, 2024. Great. If I say step of 2024, 20 and 24. Now 20 and 20 says there are 2 20s. Perfect. This looks correct. So I guess what we want now is a function blink from stone counts to stone counts. Blink. And it should be really simple, right? Blink of M, probably. Yeah. Blink M is from list with plus. Now, hang on. Should this be calling my little freaks function? No, because freaks assumes there's only one. Whereas we're going to be working with larger quantities. So from list width of do, label count will be drawn from the soaks of M. Oh, is it? I don't necessarily want... I don't want from list with. I want unions with. Because step already returns a stone counts. Sure. So you can have a list. I should be able to write pure something here, and something is like fmap times count of step label. Does that make sense? So I'm stepping the label, giving me a stone counts. I'm multiplying the results by how many there were. So I've chosen a single label and count from the input list. Input map. I'm stepping that label, multiplying the results of that by count, and then yielding that map, which will be size either 1 or 2. And then I'm unioning all of these together, and so if there are any duplicates, they'll be found. I think this makes sense. Is this type check and compile? Almost. Not really. What do you mean? Okay, let me make sure I have the right type for unions with, I guess. Unions with in data int map. Given I have an int map of A, well, an f of int map of A, which for me f will be list. So I have a list of int maps of A, and a function to combine A's. It combines them into a single thing. Yeah. So this is what I wanted. All right, could you explain the error to me as you would a child? What are you saying here? You're saying I have a function from f of quantity. No. You're saying you thought I would have oh, my parentheses are wrong. There you go. Sometimes it is kind of like, I sympathize with people who say Haskell's error messages are obtuse. I get it, like, it's supporting fancier operations, and like, if you had functions written the way they are in C-like languages, where you had like function, parent, separated by commas, parent, you could say, oh, you just are missing a parenthesis or something. Whereas what I wrote was something weird that type checks if I meant a completely different type than what I meant. And so it assumes, you know, it inferred something that could have been true but is utterly nonsense. You know, clearly I made a mistake. I wrote the wrong thing, but, you know, it didn't diagnose the mistake very clearly. Anyway, so I think that's fine. And so part 1 is sum.m.vals, I assume it's called? Nope. Data int map. How do I get a list? To list. I don't want a list. I want just the values, please. Keys, assocs, elms. That's right, elms. So let's blink 25 times, I think it was, right? Oops. 25 times. Yes. Blink. So I think this is what we want. We prepare the input. We iterate blink, producing an infinite list of what we would get if we blunked. We get the 25th element of that. We look up the elements, i.e. just the quantities, and then add them up. Not quite. What? I called prepare. What is this saying? The second argument of prepare is a string. Yes, correct. That's what it should be. But you're saying you thought it would be an input. How did you get that idea, you maniac? The blink function, yeah, it is an endomorphism. It maps a type to itself. So it's the right argument to pass to iterate, which makes sense. It would be complaining about that if that were wrong. Prepare. I'm saying prepare. So I'm taking a string, and I'm getting an input out of it. Then I'm iterating blink. So... And blink is stone counts to stone counts, and input is stone counts, so this seems fine. Have I forgotten the type of... Takes a list of A and an int. Yeah, I got the order of that right. M elms? Is that type wrong somehow? Int map A to list of A? No. I can't understand the error message I'm getting. I guess I could write this in non-point free style and see if it just like works. But I would just be inlining function composition, and I would get an error message that tells me something is wrong. I guess it would give me a chance to name the intermediate types. No, I didn't forget to say that this returns an int now. One thing we could do is try to isolate the problem. Say this, I expect to be a function from string to list of stone counts, right? So which part of the problem? So you're saying, yes, that is the type that iterate blank composed with prepare has, but that's not the type you thought it would be. Why not? So this function has type in string to single stone counts, right? You're saying, yes, there actually is a function from string to stone counts here. Oh, what am I doing? It's not string. It should be... Okay, wait. Oh, I'm so dumb. I'm calling prepare here. I've already called prepare. That's how my template works. I think it's because yesterday or the day before I actually did a separate prepare for the two steps. I think it must have been the day before. I got confused and I called prepare in part 1. Okay, this looks better. Thank you. There you go. 220,999. What an interesting number. So let me copy and paste. That's the right answer. Okay. So it feels a little stupid, as I said, to import bimap for such a pedestrian use, but it's the only convenient way to apply a function to both halves of a tuple without pattern matching on it and then just calling the function twice. Day 11, part 1. And what's part 2? Yeah, you have to blink 75 times, told you. So we'll just say solve takes an int and produces a function from input to int. I imagine this was exactly what I would write. Solve of n equals this. Part 1 is solve of 25. Part 2 is solve of 75. Fix the types. Run it again. Takes a little while, but not that long. As you can see, if we had taken this if we had simulated the process this many steps, we would be waiting here for many years for the program to finish. There, that's the right answer. Well, I'm glad I came prepared. Found a good algorithm before. You were going to have to write this algorithm anyway. And I still think there's a better one out there. One that exploits the loopiness somehow. But I couldn't figure out how to do it. And this is sparse enough that you can actually simulate, as long as you don't simulate individual stones, just all the distinct values you've found. So I'm glad, you had to do some decent algorithm for part 2. This one or the other fancy one I couldn't think of. And so it was nice that I thought this out ahead of time and didn't make myself also implement a simulation algorithm for part 1. Anyway, let's commit this and get out of here. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.